The first important thing is how to import Numpy, and I've already explained what Numpy is. The other concept that we do need to use is how to assign a value to a variable. So we use equal sign, but it doesn't necessarily mean equal. So V stands for variable, and 5 is the variable value. So a location in memory is assigned to variable v, and we assign the value 5 into it. So it is not equal to 5. V is assigned to 5 is the way that we need to read it. We can assign multiple variables to different values using brackets and comma, and that's how we do this. Let me run this one, and don't worry, I'll provide the notes that I've developed here and the link through my GitHub, so you can have access to these notes and you can look at them anytime you need. And then let's run the second one. Now it is expected that V is assigned to 5 is assigned to V, 3 is assigned to A, and 4 is assigned to B. Print is another function that is utilized to display things. And once we print those variables, you can see V is 5, A is 3, and B is 4. So they are assigned correctly. Another important concept starting with programming is order of procedures, which matters, and it's from left to right. And it matters because sometimes we don't want to explicitly show which operations should happen first, and we just want to use the intuition of the program to do so. Let's say 2 to the power of 5, 8 multiplied to 5, 8 divided by 4. These are operations that individually we don't care about the procedure, the order that they happen. But once we want to combine them and do a little bit of mathematical operation, it does matter. So here, if we had 7 plus 1 times 5, the way the computer sees it, it goes from left to right, understand the operations. Multiplication has a higher order than summation. So first multiplication is going to happen and then summation. So this is how the system sees it. If we wanted to first sum 7 and 1 and then multiply by 5, we should have explicitly distinguished that using parentheses. And then parentheses, I would say, has the higher, it is not an operator, but in a sense, it would have standed before exponentiation. So this is the order that the system is going to see and is going to act upon. And here is a bit of a, let me run these so you can see the final values are different. This one, if we didn't use the parentheses, the division wouldn't happen first, and then we would have had a completely different result. And I will add that for the sake of course. So you can see that the values are different here. First we have 6 times to the power of 1, and then the result, which is 6 divided by 7, which is different from what we expect, what we ask here. This is another important ingredient for our course. Then we have, we know how to assign variables. Here I'm assigning x, and I do want to emphasize that this is an assign, like operation is not equal. Since it is an assign and it is addressed to a location in memory, we can use the same variable name to change its own value. So what I'm doing is x is initiated to 5. We can ask Python to add 2 to the x and assign it to x again. So what it does, it goes to that location in memory, reads the value, adds 2, and then reassigns the new value to x. And it can hold the same name, or we could have changed it. So that That's exactly what happens, and x is increased by 2. Python has this nice feature that instead of going using equal, then plus, and repeating x, we can just say x plus equal to. Exactly means that plus equal means this. So if I reassign x to 5 and ask the operation to happen again, it's going to give us 7. The important note here, pond is used to make comments, meaning that once compiler says pond, it is going to ignore whatever comes after it. So we can use pond sign to make comments, which is a good practice. And I'm going very fast through these because these are very introductionary, if it's a word. And what I mean is these are simple, and we can just skip through them and go fast. This is if you find them challenging, and even if you don't, I would suggest to try to write this equation and see the result. It's a good practice. I'll leave it there for you, and you can then download this note and try to practice these. And I'm not gonna go through this one, and I'm not gonna solve it. But instead, now we have, as I promised, I want to make this practical. So we have learned how to assign a variable. We have learned how to name a variable, and we have learned about operations. Now we can utilize those and approach a design problem. Like here we have a cone shape volume, and from calculations and geometry, we know how to drive the volume of that tank using its radius, height, and pi. So suppose this conical tank has a 10 meter tall, and the radius is 5. So we have a conical with 10 as h and 5 as radius. So it has a volume. We want to design a new tank with the same height, but the volume is 30% less. And the question is how big is the radius of the new tank? So just by rearranging the variables here, and this is just math, it has nothing to do with programming, we can derive the equations for r, which is the root cause of 3 times v divided pi h times h. Now we have equations for v and equation for r. Let's start and then derive the radius of the new tank. It is a good practice. Like if I wanted to isolate this question from the entire system, the best practice would have been first import your required libraries, then assign the initial values. So we have some known values or initial values, h, which stands for height, and it is in meters. Like it never hurts to commenting dimensions that you are dealing with. Actually, it is advised. H and R are like widely used for height and radius. It might sound redundant, but I would rather to provide those details. Once we have the initial height and radius, we can calculate the original volume using this. Oh, sorry, I first should run this. So Numpy is imported and it is renamed to NP. H and R are assigned. They have the values inside them now. So I can calculate for original V. I'm avoiding to use prints to confuse you, so I just use this Just calling the variable name and running it on a separate command will provide you, or the same command would provide you with the value assigned to that variable. So we have the volume of this tank, the original tank. Now we can start going to the second phase, which is the requirement is 70% of the original volume, same height. What is the radius? So uh, I don't want to, I introduce a new variable called vnew, 70% of the original volume. So that the volume of the new tank, the desired tank, or even would have been a more accurate naming, is 180. Then I have the radius equation. I can derive the radius value, which is 4.1, 1 unit, almost 1 unit less than the original one. There are a few things here that I need to point out. I would like to emphasize again that import your libraries at the beginning of your program. Assign your initial values right after you importing the libraries and the packages, or any initial setup that you require. So those are very important. Try to be clear with your dimensions, with the abbreviations you use and what they stand for, and try to use a clear naming convention like original V, new V, or desired V, new R. Try to distinguish between those. And last but not least is, if you want to use any function defined in NumPy, you are supposed to use dot method followed by np, which, because we have renamed it. If we haven't, we should have used numpy.py. So because pi value is coming from numpy library as a float number, it is better, we are supposed to put np dot in the beginning, and that's why you see np here. And that's why that justifies abbreviating numpy. It is faster to write. And there are two general methods of naming variables. You would have capitalized the first alphabet that makes sense, or use underscore. So now with the tools that we have learned, we have developed a program that gives us the new R, and of course it could have been faster, better, and a bit more advanced. But even with the simple tools we have, we can approach a design problem. After these, now we move to another concept in math that we as engineers utilize a lot, which is complex numbers. People dealing with aerobatics, vibration, control theory, like they might be more exposed than other engineers to these numbers, but it is good to know about them. So complex numbers, they have real and imaginary part. I'm not going to go deep into the math part of it, but the way that we show them in Python is C stands for complex, A real part, B imaginary part, and J is the imaginary unit, which is the most easiest way of defining it, is equal to -1, if you would have accepted that from me. So we would have access to the real part of C using dot real, dot image is imaginary part, and dot angle is the phase of the complex, the number on the real imaginary coordinate. So we can get the phase or angle as well. And we can do all the operations without even knowing how to do them. So if we define A and B as variables, you might want to see them. Print A. I'm just going to print A. That is going to be seen like this. And let's have B2. Yep. We will have access to real part of A. I just used A here. You could have visualized B as well. And then we can do addition, multiplication, division. Addition or subtraction are really easy when it comes to complex numbers, but if you might remember from, or if you don't know, so multiplication of complex numbers are a bit of work, and AC minus BD, like, or division itself is a big, an I is old-fashioned way, IJ. MATLAB uses I as well, but Python uses J for the unit. So without going through that pain, we can just use Python to get those values, and there we go. We get the real part, imaginary part, and even the angle can be utilized. And I'm asking to reprint D, which is the multiplication result, and the division as well. So these are very useful tools if you're dealing with them. But more general tool that we need to use, that every engineer that programs needs to know about is rounding a number, because sensors, actuators, all the tools that we utilize to implement a program into a real board, into a physical board, has a tolerance, has a accuracy level, and we need to know those in order to feed them to the machine. And we need to be able to reshape our calculations, because numerical calculations, they come with errors, they come with different accuracy level and everything that you know better than me. And so we need to be able to make these talk to each other and be aligned. And rounding is one of the most powerful tools. These are all the rounding techniques you have at your reach in Python. Round, which is initially defaulted to 0 decimal points, just rounds the number to the level of decimal point that you have defined. Floor goes to the floor of the number, ceiling goes to the ceiling of the number, fix goes towards 0, arent goes toward the nearest integer. It's a combination of ceiling and floor. And then we have trunc, which just eliminates the fractional parts. And those are different techniques that you might use in different scenarios. I am just gonna use print, and as you might know, this goes to the new line. So I don't focus on these, and like if you have question, or if it's interesting for you, it's better to start searching and seeing, like, learning through the struggle, I would say. So I'm gonna heavily focus on the calculation sides, and if you see something that you might need explanation for, it's always better to search. But then for this one, as you can see, like, it puts input array, and then the \n goes to a new line and print 6. So this is the original array. I will explain this shortly, but if we accept that this value exists, we can see the function of each of those. For rounded values, as you can see, it goes to 1 decimal point, as I've asked, and the floor goes to the floor, ceiling goes to the ceiling, fixed towards 0, and as it goes, and etc. So this tool is essential for us. Why? Because we need to be able to produce results in the domain that a machine can understand it. The parts that talk to each other. Let's say you're making a robot. So that's why it is important. And not only that, there are computational errors associated with every numerical computation, no matter what language. So we need to kind of diverge from those and